Hello and welcome! Every time you send a message, share a photo, or stream a movie, you're part of this huge, invisible dance of information. Today, we're going to pull back the curtain on how modern computer networks actually work and follow the incredible journey your data takes to get across the globe in literally the blink of an eye. I mean, really think about it. It feels like magic, doesn't it? You hit send on a photo to your friend who's on a completely different continent and boom, it's there. But behind that super simple action is this high-speed, globe-spanning adventure that is honestly nothing short of extraordinary. Now, for this whole thing to work, for any journey to be successful, you've got to have some rules, right? Rules of the road. And before our data can go anywhere, it needs a really clear system to follow. These are the absolute fundamentals that govern all communication, from you and I talking to a super complex data transfer. Okay, so take a look at this. At the most basic level, its power is in its simplicity. You have a sender, that could be your phone. You have a receiver, let's say your friend's computer. You have a message, the photo you're sending. And it all has to travel across a medium, which is just the physical path connecting them. So when we're talking about computers, we need 5 key things. We've got our message, our sender, and our receiver, of course. Then there's the transmission medium, the physical path, like fiber optic cables. But honestly, the most important piece of this whole puzzle is the protocol. Just think of it like a shared language. Without that set of rules, 2 devices could be connected, but they wouldn't have a clue what the other one was saying. So how does your massive, high-resolution photo actually travel across the internet? Well, it doesn't go in one giant piece. Instead, we break it down into these tiny, super efficient little vehicles. That's right. Instead of trying to shove one massive file through the tubes of the internet, your computer literally chops it up into thousands of small, manageable pieces. We call these data packets. And the logic here is pretty simple, right? It's way faster and more reliable to send a bunch of small envelopes through the mail than one giant, oversized crate. And this is where it gets really cool. Each one of those little packets gets sent out on its own. They don't have to follow each other in a neat little line. Just like cars on a highway, they can all take different routes to avoid traffic jams or any other bottlenecks, all of them just trying to find the quickest path to the exact same destination. Every epic journey has to have a starting point. And for our little data packets, that journey begins right where you are, in your own home or office. This starting point is your local area network, or what we call a LAN. You probably know it better as your Wi-Fi network. It's that small, private network that connects all the devices in your immediate area, whether that's your house, a school campus, or a big office building. Let's stick with our road trip analogy for a second. If the data packet is the car, then your LAN is basically the driveway and the local neighborhood streets. It's that essential first mile of the journey that gets your data out of the garage and heads it towards the on-ramp for the global superhighway. All right, so our packets have left the neighborhood, they're on the on-ramp, and now they merge onto this vast, interconnected network of networks that we all call the internet. This is where the real long-haul travel begins. So as our packet leaves that small-scale LAN, it enters what's called a wide area network, or WAN. Think of it this way. The LAN is your town. The WAN, well, that's the entire country's highway system. It spans countries, even continents, connecting all those little LANs together to form the backbone of the internet. Okay, so how does a tiny little packet navigate this enormous highway without getting lost? It gets directions from these amazing devices called routers. A router's whole job is to act like a super intelligent traffic cop at a crazy busy intersection, looking at where each packet needs to go and pointing it down the best possible road to get there. Now, this diagram might look a little complicated, but the main idea is actually really simple. When a packet shows up at a router, the router checks its destination address and just forwards it to the next router on the path. Each one of those jumps is called a hop. This hop-to-hop delivery process is what moves your data across the entire world, with each hop happening in a tiny fraction of a second, often zipping through fiber optic cables at nearly the speed of light. So, after hopping across cities, oceans, and continents, our thousands of little data packets are finally pulling into the destination, ready for the very last step of their journey. Remember how each packet was just one tiny piece of your original photo? Well, the receiving device is like a master puzzle solver. It collects all of those individual packets, which, by the way, might have arrived all out of order, and it reassembles them perfectly to put that original file back together again. The journey is complete. And what's so amazing is that this whole process, slicing data into packets, hopping them across this huge network, and then putting them back together at the end, it's the engine that powers pretty much everything you do online. We're talking Wi-Fi, your cell phone, cloud computing, streaming movies, online gaming, all of it. And speaking of the cloud, let's just bust a myth right now. The cloud isn't some fluffy thing up in the sky. It's a very real, very physical network of massive data centers, just filled with powerful computers called servers, all connected to the exact same global data highway our little packets have been traveling on. So, from a few simple rules of the road to a global superhighway, the journey of your data is truly an invisible marvel of modern engineering. And it really makes you wonder, doesn't it? As billions more devices and people come online, what will the data highways of tomorrow need to look like to keep up with all of us?